Day 18 of 90, and today we're killing a myth that virtual functions are free. They're not. Here's a real rendering loop where one virtual draw call eats 40% of frame time in the profiler. Same logic, same math, but the CPU stalls on every call. By the end of this video you'll know exactly what of table costs, when that cost matters, and 3 ways to get runtime polymorphism without paying it in your hot path. Let's get into it. First, the mechanism. When you write a class with a virtual function, the compiler adds a hidden pointer to every object, the vptr. It points to the table, a static array of function pointers, one per virtual method. When you call ptrdraw, the CPU loads the vptr, indexes into the table, then jumps to whatever address it finds. That's 2 dependent memory loads before a single instruction of your actual function runs. The compiler has no idea which function it'll be, so it can't inline anything. And inlining is where the real loss hides. A non-virtual one-line getter inlines to 0 overhead, the call literally disappears. A virtual call can't, so you keep the function call machinery, you keep the stack setup, and you block every optimization that crosses that boundary, constant folding, loop unrolling, vectorization. On top of that, the jump target is data dependent, so the branch predictor often guesses wrong. A mispredict on a modern CPU is 15 plus cycles. In a tight loop over a million objects, that adds up fast. Now, when does this actually matter? At an interface boundary, almost never. If update runs once per frame per subsystem, the table lookup is noise next to the work inside. Virtual dispatch is the right tool for plugins, device drivers, anything where flexibility beats nanoseconds. The cost only bites in tight inner loops per pixel, per particle, per packet, where you call the same kind of object millions of times and the function body is tiny. That's your decision rule, virtual at boundaries, not in hot inner loops. Before we optimize, let's make the code correct. Always mark overrides with override. Write void draw, override, and if the base signature ever changes, someone adds a const, changes a parameter, the compiler errors instead of silently creating a brand new function that never gets called. That's a classic bug that override kills for free. And one more non-negotiable, if you delete a derived object through a base pointer, the base destructor must be virtual. Skip it and the derived destructor never runs, your unique _PTR members leak. Polymorphic base class? Virtual destructor. No exceptions. Here's the lever for performance, final. Mark a leaf class or a method final, class fast renderer final, public renderer, and the compiler now knows nothing can override it further. When it sees a call through a fast renderer asterisk, it can prove the exact target and devirtualize, turn that indirect jump into a direct, inlineable call. In a tight read loop, that one keyword can collapse the whole table cost back to 0. Final isn't just documentation, it's an optimization hint the compiler genuinely acts on. But the strongest fix is to not be virtual at all when you don't need runtime flexibility. Enter CRTP, the curiously recurring template pattern. Instead of virtual draw, you write template class destruct renderer and the derived class inherits as struct fast, renderer fast. The base calls static _cast asterisk, this, drawimpl. The type is known at compile time, so the call inlines completely, no vptr, no table, no mispredict. You get polymorphic style code that compiles down to a direct call. The trade-off, it's compile time only, so no heterogeneous containers of base pointers. When you do need a mixed collection but know all the types up front, reach for std invariant and std visit. Replace vector unique _ptr component with vector variant physics, AI, render. No heap allocation per element, the object's life contiguously for cache-friendly iteration, and std visit dispatches through a jump table. The predictor handles far better than of table. Closed set of types? Variant. Open, plugin style set? Keep virtual. Day 18 done. Virtual is for interfaces at boundaries, use override and final to stay correct and let the compiler devirtualize, reach for CRTP or std invariant in the hot path. Subscribe for day 19.